Good morning, dear students. This is class 9th lecture, and this lecture related to sound chapter. And the topic is what? Reflection of sound. In this lecture, today we will discuss about the concept of reflection of sound and its importance in daily life, or you say that real life. Just say the complete concept of reflection of sound in easy way. The first thing that is about reflection. Reflection generally means what? Bouncing back of light. That is related to light concept, but here we have to study about what? Sound. So bouncing back of sound wave. Bouncing back of sound wave from rigid support. From rigid support is defined as reflection of sound. I think most of the students are confused what is the reflection of sound and what is the law of reflection of sound. Reflection of sound means only you have to define about the reflection concept, and laws of reflection, that you have to mention the two basic laws about which we will discuss just later, no matter. But bouncing back, suppose a rigid surface is given here, rigid surface, and this one is what? Incident sound wave, and this one is what? Reflected sound wave. Clear? Very simple concept. Whenever the incident sound wave strike to any rigid surface, this is the rigid surface. Suppose this one is what? A wooden cardboard-like structure. And whenever the incident sound wave strikes this surface, then after striking, just reflected back in the same medium. This is the sound wave, and this sound wave just produced by here a simple instrument, that is what? Stopwatch. Here, when the stopwatch is on, then sound just produced and then travel, or you say that propagate, and then after reflection from this rigid cardboard, and suppose you want to hear about this sound board, reflected sound, then you have to adjust your ear some more distance here, then you will hear the sound wave here, just like tick tick tick. This type of sound produced by this sound producing device, that is what? Stopwatch. And this one is a human ear. Here. So the next thing is what? After just reflection of sound, the next thing is what? Reflection related. That is laws of reflection. Laws of reflection. Very important concept about laws of reflection that you will later study in next class, that is in class 10th. At the same concept about This sound you will learn here, that will be utilized in your next class, class 10 in light chapter. Here, this is the sound concept, and in sound we are just studying about the reflection of sound, and the reflection means was bouncing back of light, not light, bouncing back of sound, bouncing back of sound wave from a rigid support, from a rigid support is defined as a reflection of sound. Clear? And then the laws of reflection. There are two important laws regarding reflection of sound. The first law, just listen step by step, everything will be clear. Very simple way. This is the normal, and this one is what? Angle of incidence, and this one is angle of reflection. This one is incident sound wave, incident sound wave, and this one is reflected sound wave. Clear? Incident sound wave, reflected sound wave, and normal at the point of incidence. This is the point of incidence. Point of incidence, POI. Listen again from starting. This is the sound producing instrument, or you say that device, no matter, stopwatch, just producing sound, and then sound travel from this point to this wooden cardboard, rigid support, and then after reflecting from this cardboard, the sound just travel in this direction, and when you just adjust your ear at this point, then you can hear the sound produced by this device. Clear? And then after, the laws of reflection. Listen about the laws of reflection. What is the laws concept? The two things about law. First, incident sound wave, reflected sound wave, and normal at the point of incidence. Suppose this point is what? O. See, incident sound wave, reflected sound wave, and normal at the point of incidence, at the point of incidence, all lies in the same plane, all lies in the same plane. Clear? Very simple law. And then after second one is too much easy. This one, angle of incidence always equal to angle of reflection. That is angle I is equal to what? Angle R. They are the two laws related to your reflection of sound. Listen again from starting. This is the incident sound wave. That sound wave is what? That is incident towards the rigid support. And this one is what? Suppose naming this one O, P, and this one Q. PO is the incident sound wave, and OQ is the reflected sound wave. Clear? And these two sound waves meet at a point O. That is what? Point of incidence. Incident sound wave, reflected sound wave, and normal at the point of incidence all lie in the same plane. I will say that plane of paper. Here, the second law is that is angle of incidence. Angle of incidence always equal to angle of reflection. An angle of incidence, you can define also angle of incidence, the angle between the incident sound wave and normal. Incident sound wave and normal. And angle of reflection, the angle between the reflected sound wave and normal. Clear? So except this definition and laws of this reflection, there are so many terms related to reflection of light, just like applications of reflection of sound. The most important application, that is sonar application, in detecting any object exact position with the help of reflection of sound. We will discuss today just after few terms. And the next term is what? Just listen about the applications, megaphone or bulb horn. These are the two applications, that is what? Totally based on reflection of sound. Clear? And next one is stethoscope. Stethoscope. And then after, the important terms, that definitions always asking examination. Echo. Echo means that is the reflected sound. And when such type of reflected sound occurs due to multiple reflection, or you say that due to occurs by only one time reflection, no matter, whenever sound heard by the reflection process, then that sound is what? Echo. Clear? So just see after this, you see the concept of echo. Very simple concept. In the echo concept, that is totally based on reflection phenomena. Clear? Reflection of sound. Echo means nothing, you said that is the reflected sound. Reflected sound. And reflected sound after multiple reflection, or you say that by one time reflection, when you just hear the sound just after producing the sound one times, when you are hearing the sound again, then that sound is what? Reflected sound, or you say that echo. But the one important terms that is necessary for the production of echo, or you say that the minimum distance for echo production. For this calculation, you should learn about the time interval gap between the original sound produced and the reflected sound here. That is what? 0.1 second. 0.1 second or 1 upon 10 second. 1 upon 10 second. When this concept is known, then you can calculate the value of minimum distance up to which an echo can be here. Clear? And above this distance you can also hear, but below this you can't hear your reflected sound or echo. Clear? So calculation of this one, just say speed of sound. You are knowing very well. Speed of sound, that is formula here. Speed is equal to what? Distance upon time. So speed here 344, and we will use what? 2 times of distance, because one time when you are just producing the sound, then sound travel the distance somewhat, and after reflection traveling the same distance towards yourself. Clear? It means the distance, just in case of producing from yourself and further reflecting from that particular rigid support to coming back towards us. Clear? That is the distance 2d upon time. The time is here 0.1 second. Then 2d is equal to 344 into time here 0.1, that is equal to 34.4. 4, and then D is equal to 34.4 upon 2, that is equal to 17.2 meter. Because the speed of sound, that is 344 meter per second. Speed of sound, that is varied from medium to medium and also vary with respect to temperature. Whenever temperature increases, then sound increases, and temperature increases by 1 degree Celsius. This is the very important concept. Whenever temperature decreases by 1 degree Celsius, then sound increases by what? 0.16 meter per second. Clear? It means speed of sound may be differ, but we are using what? 344 meter per second, and the distance just by one time from observer to rigid support, and second time rigid support to observer, that is D and D. 2 times adding wherever, then 2D, and upon time interval, that is 0.1 second. Then by simplification we will get what? 2D is equal to 34.4, and then D is equal to what? 17.2 meter. Here, this is the minimum distance up to which we can hear the reflected sound. Here, this is the concept of echo. And then after you are familiar with the audible range, that is very easy. 20 hertz to 20,000 hertz, and below 20, that is infrasound, and above 20,000, that is ultrasound. So we will discuss about these two terms, infrasound and ultrasound, in next lecture, but in today's lecture we will just discuss about the most important topic of reflection of sound, that is sonar. Clear? So just see the concept of sonar application. Here sonar stand for SO, that is sound, and N for navigation. Sound, navigation, and ranging. This is the device totally based on reflection of sound. Here, let's see how this device works. Suppose any object just lie inside the water depth. This is the object, and a ship, that is having in floating condition above the water level, somewhat part just below the water level, no matter. And here two terms, that is very important terms. I will say that setup in the sea, floating this SIG. That is one is transmitter that is transmitting an ultrasonic wave. Clear? This transmits the ultrasonic wave, and this wave, when just propagated, then after reflection from this object reflected back, and then another setup is what? Receiver. This is the transmitter and this is the receiver. Clear? This transmitter is for transmitting ultrasonic wave towards this object, and this object means what? Having a rigid concept, and then reflected back the sound, and this is the receiver system. And when just reflected sound coming back, then by somewhat about signal system having some buzzer like system or having some light system that indicates that sound wave just received. Clear? This is the transmitting wave, and this one is the receiving wave. Clear? And how to detect the exact position of this object from this SIG? That is totally based on reflection concept. One side, if the distance is what? D, then this one side, the distance will almost equal, that is what? D. Clear? Suppose this wave whenever generated, then time will be some what amount time, and during transmission and receiving there is a time interval gap, and then time interval must be noted. Clear? And the time is well known. Then speed is equal to what? Distance upon time. It's a very popular formula that is given in class 9th standard, first chapter, that is motion. Clear? Let's see, after this, speed equal distance upon time, and distance here, that is one time, d from transmitter to object and further object to receiver. This is the total distance, and this one is given by d plus d upon t. This one is speed, means well known, representing by v. Then d plus d means what? 2d upon t. D is equal to 2d upon t. Then d can be calculated by v into t upon 2. This is the required formula. By using this formula, we can calculate the distance of an obstacle or object from the particular setup. I will say that transmitter and receiver setup. Clear? With the help of this formula, we can find out. So I was just talking about the range of sound audible condition, 20 to 20,000, and below 20, that is infrasound, and above 20 hertz. The unit of frequency is what? Hertz. And above 20,000 means what? Ultrasound. And some animals that are able to, you say that, produce or hear just infrasound, rhinoceros is capable for producing infrasound. I will say that can hear also, and dog and bat can produce ultrasound or ultrasonic wave, no matter. So the concept in between these two rays, that is what? Audible range. And beyond these two, having range this side left, I will say that less than 20 Hz infra sounds, and above 20,000, that is ultrasounds. And the next one thing is what? Reverberation. Let's see. Reverberation. Reverberation means very simple. That is persistence of sound wave. Persistence of sound wave due to multiple reflection. Due to multiple reflection. Whenever such type of phenomena is going on, then there is what? Reverberation. Clear? And we will solve some numerical also based on this distance formula. That is what? Distance of an object from any particular device setup, or you say that from sonar system. Clear? So just see the numerical based on this topic. Just see two questions given on two concept. First question that is based on echo concept, and second one based on sonar concept. If the question's visibility is not clear, then don't worry. I will read the question and you will just understand about the questions and solution both. Just listen. A man standing 825 meter. 825 meter. Let's see the solution of first. 825 meter away from a cliff, just like rock, and having steep rock. Clear? In such a way that a concave structure will obtain. Fires a gun. This is given what? V is equal to given, that is 825 meter, and fires a gun. After how long will it hear? Here the concept of how long means not the distance concept. You have to calculate what? Time concept, because the speed of sound in air, speed of sound, that is V is equal to given 330 meter per second. Clear? So after how long will it hear the echo or its echo, no matter. Just see the time will be V, that is speed formula. You have to calculate what? Time. First, always remember two things: what you have the given terms and what you have to find out. So speed formula, V is equal to what? 2d upon t, and we have to find out t. T is equal to 2d upon v, and the distance is 825 into 2 upon speed here 330. We cancel out 1 2, 2 6 12, and 2 5 10, and then say 825 and here 165, and cancel out 5 5 25, 5 6 30 into 32, 3 balance 5 to 5 3 8, means 5 times. So time is equal to what? After 5 seconds, the person, or you say that a man, can hear the echo. Clear? Just listen from starting again. The two things is given: distance concept 825 meter given, and the speed of sound also given. You have to find out the time concept. After how long will it hear its echo? Clear? First time just distance traveled by sound, and second time distance reflected sound travel. Clear? Distance traveled by reflected sound. One time just distance traveled by produced sound, and second time distance traveled by reflected sound. That's why we are taken what? 2d upon t, and then t is equal to what? 2d upon v, and distance given, speed given, then multiplication of 2 and cancelling out gives what? The simple result 5 seconds. Clear? Let's see the second thing. Solution of next one. Very easy concept. You will just try to solve out all the numerical that is given in your book. Then you can improve your concept. Only one simple formula. Speed is equal to what? Twice of distance upon time, and distance is equal to speed into time upon 2. Clear? see the second question. A sonar station picks up a return signal after 3 seconds. Means in solution 2 what is given? T is equal to 3 seconds given. And how far away is the object? It means you have to calculate what distance. And further what is given? Speed is given. Speed, that is Vs, here that is 1440, representing speed of sound in water, that is 1440. 1440 is given. Clear? So time given, speed given, then formula you are knowing what? V is equal to 2d upon t, then d is equal to v into t upon 2. Speed is given, what? 1440, and time also given, 3 upon 2. Then cancel out 214, 2 2 is 4 and 0. Clear? Just see 3 2 is 6, 3 7 21, 2160 meter. Clear? So the object is at a distance of 2160 meter. Clear? Very simple. D is equal to what? 2160 meter. So don't worry about the visibility concept. Is this visible or not properly? No matter. I am just going to read once again. First question: a man standing 825 meters away from a cliff, that is steep rock, having a concave structure, fires a gun. After how long time or how long will it hear its echo? It means you have to calculate time. Speed of sound in air is 330. Just time calculated before this solution. What? Time is equal to 5 seconds. And second one, a sonar station picks up a return signal after 3 seconds. How far away is the object? Here is speed and time given. You have to calculate what distance. Then formula is v is equal to 2d upon t. Then d is equal to v into t upon 2. Then multiply v with time, that is 3, and dividing by 2 gives what? 2160 meter. Clear? You can solve out so many methods that is based on the reflection concept. If any confusion or any problem in any question, then you can ask. So that's all for today. Have a nice day.